Assalamu alaikum. This is our 10th lecture of managerial economics. I am going to upload this video second time because last time there was some issue in record video. So to facilitate my mcom students, I thought to record it again. You should be thankful to me. So as you know, in previous lectures to discuss about production and costs in short run. And today we are going to discuss production and costs in the long run. Before discussing the long run production and cost, let me give you an overview of the lecture. First of all, we will introduce the production isoquants, then properties of isoquants. After that, we are going to discuss in detail about types of isoquants, and at the end of the lecture we will discuss marginal rate of technical substitution and iso-cost curves. First starts from production isoquants. We also called it production indifference curve and equal product curve. So in the long run, as I told you in previous lectures about long run and short run, as I told you that in the long run all inputs vary. We know that in the long run firm can expand plants, new firms can enter and exit from an industry. So big question arise here, what is the use of isoquant? Basically isoquants are used to study production decisions. Now we will discuss the concept of isoquants. Basically isoquant theory concept relate to new classical school of thought, and Professor Higgs is father of it because its behavior looks like a indifference curve. An isoquant is a curve showing all input combination of labor and capital which are capable of producing a given level of outputs. So the shape of isoquants are downward sloping and falling left to right. If greater amounts of labor are used, less capital is required to produce a given output. In order to explain it, look at this diagram. These are typical isoquants, and you can see that on x-axis are units of labor and on y-axis are units of capital. At point A, producer to get 20 units of labor, to get 20 units of labor, he is leaving 20 units of capital. But below a point, you can see that to get more units of labor, firm leaving only 10 units of capital. But on above a point, to get 5 units of labor, firm leaving 10 units of capital. So substitutability exists here, but not perfect substitutability. That's why an isoquant curve is downward sloping and fall left to right. You can see that at this diagram. An isoquant curve, all different points shows equal level of production, but higher isoquant shows high level of output and lower isoquant shows lower level of output. Here you can see that Q3 shows high level of output which is equal to 300, and Q2 shows low level of output as compared to Q3, and Q1 shows lowest level of output which is equal to 100. Next we will discuss properties of isoquants curve. First is isoquants shows Magnitudes. Isoquant shows materialistic approach can measure its production. As I have discussed in previous lecture, an isoquant shows different bundles of two goods which give equal satisfaction of a consumer. So basically, an isoquant curve shows psychological situation of a consumer. We cannot measure it and we called it ordinal approach. But an isoquant shows materialistic approach and isoquant shows that by using different units of labor and capital, how much production we can get. An isoquant falls from left to right for use of additional unit of labor, leaving less units of capital. As I said in a previous slide, that for use of an additional unit of a labor, leaving less units of capital. Next is an isoquant convex to the origin. In real life, an isoquant has elliptical shape. Convex part shows economic units. Production technique are only technical efficient inside the ridge lines, and the part outside the ridge lines shows uneconomic units, or you can say that inefficient production technique. Isoquants have oval shape. This and isoquants don't intersect each other. So every isoquant shows different situation. In order to explain this diagram, you can see that isoquants have oval shape. This diagram shows that economic and uneconomic regions. On x-axis are our labor units, and on y-axis or vertical side shows the capital units. Here may question arise that why an isoquant has oval shape, because when a producer uses more units of capital and more units of labor or both, then necessarily the total product eventually decline, and it has a elliptical shape. You can see that here are two ridge lines, upper ridge line and lower ridge line. The area which belongs to inside the ridge line is called negative slope is called negative slope and economic region. So positive slope portion area in isoquant is upper ridge line and lower ridge line area. Lower ridge line area the area where marginal productivity of labor is 0, and upper ridge line the area where marginal productivity of capital is 0. So positive slope area is relevant and also called inefficient techniques area or uneconomic region or irrelevant, and this area not feasible for production. On other side, inside the ridge lines, the area where firms use efficient techniques and also called full economic region, which is feasible for production, and firm will operate in second stage area between the ridge lines, and we have seen that stage first marginal productivity of capital above the ridge line, marginal productivity of capital is negative, and in stage third, marginal productivity of labor is equal to negative. Below the ridge line, marginal productivity of labor is negative below the ridge line, and marginal productivity of capital is negative above the ridge lines. So isoquant are negatively sloped and convex to the region, and negatively sloped area feasible for a firm. So firm will operate in this area. So negatively sloped area due to margin rate of technical substitution, where to get one more unit of labor we leave less unit of capital. So margin rate of technical substitution of labor for capital is falling. Both inputs are substitute but not perfect substitute. So margin rate of substitution is falling here, and margin rate of technical substitution is equal to margin productivity of labor over margin productivity of capital. So margin productivity of labor here falling, and margin productivity of capital is increasing here. So this is also called the slope of isoquant, where margin rate of technical substitution is falling or diminishing. That is the point where isoquant is. That is the point of slope of isoquant, which is negative. And isoquant cannot intersect each other. You can see that in second diagram, both isoquants are intersect each other. So we can say that these are if they are intersect each other, we can say that result will be occurring inconsistent. So isoquant cannot intersect with each other. We should have a bird eye on types of isoquants. Here are some types of isoquant. The isoquant curves can be classified on the basis of the substitutability of factors of production. These types are linear isoquant, right angle isoquant, kinked isoquant, and convex isoquants. Linear isoquant. An isoquant assumes perfect substitutability of factors of production. A given commodity may be produced by using only capital or only labor, or by an infinite combination of capital and labor. So here is perfect substitutability, where margin rate of technical substitution is constant. So if we get 1 unit, increases 1 unit of labor, we also leaving 1 unit of capital. For example, perfect substitutability, gas and oil, energy and time. So gas and oil and energy and time are a perfect substitute with each other. Next type is lentif isoquant. You can see that here it has L shape, and we also called it right angle isoquant curve. Lentif, who was awarded Nobel Prize in 1973, basically for his fine work in input-output analysis. So and this is one of the types of isoquant curves where there is a strict complementary with no substitution between the factors of production. So here substitutability 0, and here perfect complementary. According to this, there is only one method of production to produce any one commodity. This curve is also known as lentif isoquant, input-output isoquant, and is a right-angled curve. So here the only one method of production is used, and substitutability of factors of production is 0, and here is perfect complementary. For example, if a firm want to produce a bicycle, firm need to have 2 wheels and 1 frame. So we used it with fixed proportion. Next is convex isoquant. So it is also called typical isoquant because it is convex to the origin, and you can see that here is continuous substitutability of capital and labor. only over a certain range beyond which factors cannot substitute each other. So here is assumes continuous substitutability of capital and labor, and its shape is convex to regions and it falls left to right. So it is also called typical isoquant, convex isoquant, smooth convex isoquant. This is the kinked isoquant shape, and which shows the limited substitutability of capital and labor, and there are only few processes for producing only one commodity. Substitutability of the factor is possible only at the kinks. So you can see that here are different points which are A, B, C and D, which joining with each other, and we call it kinks. So only substitutability possible on these points, and substitutability of factors is possible only at the kink. This is also known as linear programming isoquant. You can see that here on x-axis are labor units and on y-axis are capital. So firms using only limited processes of producing any commodity, or here substitutability of factors is possible only these points, uh, which are shown, which shows the limited substitutability. Yeah. So by joining these points, we get a kinked isoquant. Next topic is margin rate of technical substitution. The margin rate of technical substitution is the slope of an isoquant and measures the rate at which the total inputs can be substituted for one another while maintaining a constant level of output. So basically, margin rate of technical substitution is the slope of uh, isoquant. So where to get one more unit of labor, we leave less units of capital. So margin rate of technical substitution of labor for capital is falling. So margin rate of technical substitution is also equal to marginal productivity of labor over marginal productivity of capital. So it shows the negative sign, and negatively sloped area shows due to margin rate of technical substitution, which shows the slope of isoquant. So the minus sign is added to make margin rate of technical substitution a positive number. Since change in capital over change in labor, the slope of the isoquant is negative. Margin rate of technical substitution can also be expressed as a ratio of two marginal product, as I uh, discussed in previous uh, slides, that margin rate of technical substitution is equal to marginal productivity of labor over marginal productivity of capital. So here marginal productivity of labor is decreasing and marginal productivity of capital is increasing. As labor is substituted for capital, marginal productivity of labor decline and marginal productivity of capital rises, because margin rate of technical substitution to diminish, falling and diminishing. Margin rate of technical substitution is equal to minus change in capital over change in labor, which is equal to margin productivity of labor over margin productivity of capital. Next is isoquants curves. Isoquants curves show various combination of input that may be purchased for a given level of expenditure at given input prices. So here WR represent the prices of labor and capital, W represent the prices of labor and R represent the prices of capital. Here k is equal to c bar over r. Here c over r is the intercept and minus w over r is the slope of the isoquants line. So here minus w over r represent the slope of an isoquants curve, which is negative. So here w this equation, we can get this equation from budget line equation, which is equal to c equal to rk plus wl, and by solving this equation we can get k is equal to c over r. C over r represent here the intercept of k, and minus w over r represent the slope of an isoquants curve, which is negative. So k intercept is c bar over r. So minus w over r shows the slope, and c over r is the intercept of k. We also explain these curves by graphically. You can see that on x-axis are labor of units and on y-axis are units of capital. So by using the units of labor and capital, we can also purchase it by given level of expenditure. So here you can see that when our intercept is 8, so our isoquants line is below, and when our intercept is 10, our isoquants line is above. So here minus 1 over 2 um, represent the slope, and here k is equal to 10 minus 1 over 2 L. So when our intercept will be greater, our isoquants line shift above, and when our intercept will be low, our isoquants line shift will be left side. Thank you. Allah Hafiz.